Hello. Today we'll talk about lists. Lists are a wonderful data structure that's built into Python. And what they give you is an ordered collection of items. So it's just a collection of things, kind of like a list that you'd make, just like the list in the English language. And it is so it makes up a sequence. So our strings were an ordered collection of characters. Lists are an ordered collection of anything. So we can have a list which is a bunch of numbers. We can have a list which is a mixture of things, a letter, string, a couple of numbers, a boolean, a floating point number, whatever we want. In fact, we can even have lists within lists. So a list is a collection of items. It has an order. And you can put anything in it, and you can make them as long as you want. So let's take a look at let's make up a list here of strings of animals: cat, dog, cow, fox, deer, whatever else I might have. Horse. There we go, there's a nice little list. So what do we notice about lists? Well, there's commas that separate the items, and then square brackets on the end that indicate that we're dealing with a list. Now, what we find common in Python is that once you've learned how to handle one type of data, you can often carry that over and use it on another type of data. That's one of the beauties of Python. So in this case, we have a sequence of things, and we could do things that we know how to do from strings, which was another sequence, specialized sequence. So for example, we can look at L of 1, which is dog. Remember, as before with strings, counting starts at 0. So if we wanted cat, that would be L of 0. As before, negative indices work, so that'll give us the last one in the list. We can look at slices from 1 to 4, for example. Works just like it did before. And all the things we did with slicing work just fine with lists. In works, so we can say that'll give us a boolean. Cat is in the list. True. Moose in the list is false. We can, because we have in, we can now walk through the list. Remember, it's ordered. So I can say for animal in list print animal, and I'll put a comma after it so we don't get character turns in there. And there's all the contents in my string, and notice they are in the same order that we put them in the list. Other things that we know, we can find the length of the list. There's 6 items in the list. And although we don't use it all that often, we can do things like, let's take a list 1, which is 1, 2, 3, and a list 2, which is A, B, and C. And I forgot my quotes. Quote. And I can now say L1 plus L2. That creates a new list, which is a concatenation. So it's concatenation just like we had with strings, just as another sequence of items. And I can also do something like 3 times L1, which takes L1 and concatenates it 3 times, much again as we did with strings. So those are all things that you know how to do from strings, and you get to do them with lists. However, we get to do more, even more things with lists. Unlike strings, lists are mutable. So let's go back to my string L with the animals. I can say, well, let's change cat, which is item 0. Let's make that equal to moose. So what I've done there is I've changed my list. Now the first item at index 0 is moose. And that's because this is mutable. I can change individual things. I couldn't use the square brackets on the left side of a string, but I can use them on the left side of a list. We can do things like, let's take a look at our L1. That was 1, 2, 3. So we can do L1 dot append, and we can append something on there, such as the string XYZ. And what do we get? We get 1, 2, 3 with XYZ appended on there. Notice that the L1 dot append didn't return anything, so we had the side effect of L1 being changed. I can do so let's go back and put our L1 back to where it was initially. So we had L1 being that, we had L2 being the letters. So what's L1 dot append of L2? Well, then we end up with so notice this time we appended another list, and so it put it, it appended the list, it stuck a list onto the end. Let me go back, let's put L1 back to where it was. L2 is still the same, and notice the difference if I do an extend of L2. And we see that L1 now has is all one list with the contents of L2 tacked on to the end. So it's a concatenation of the items in the list. So that's the difference between append. Append appends to the end whatever that item is, and extend takes the contents of the list and inserts it. You find yourself using append frequently. You will find yourself using that a lot. Now, one of the most useful ones is one of the useful tools that we have is split. So let's take a string to be or not to be. I'll leave the punctuation out of it. There's a string. Look what split does. If I take string and I split it, split can take parameters. Let's go back and look at that. S.split. It can take parameters in there, but if we take no parameters, it defaults on any kind of white space. Blanks, tabs, carriage returns, whatever. And look what we get. We get a list of the strings that were in the original string. And in particular, it's really nice to collect those into a named named string. It's one of the most useful things. You're going to use that a million times in this course because, for example, you might read things in from files, and those will be read in as a string for every line of the file, and you'd really like to split it up into individual words. What else do we have? There are some other things we can do, such as, let's see, do we still have our animals? Sure, there we go. We can do L.sort. Now let's go sorted of L. That goes and sorts them, in this case in alphabetical order, putting cow first, and then deer and dog, and then fox, horse, and moose. Notice that sorted did not change L. If I want to change L itself, I can use L.sort. So here we see the difference. Sorted is a function. It returned a list. L.sort is a method. It changed the list itself. So the sorted and the sort gives you a really nice, does a really nice job of contrasting between the function sorted and the method sort. The method sort changes L. Sorted doesn't change L. It creates a new list with the items in sorted order. Finally, let's take a new list. Let's take some numbers. And I could sort these if I wanted to. I can do sorted of L5. It sorts them just as we would expect them to. But since I was using sorted, it didn't actually change L5. But there are some other nice functions. Like, what's the biggest number in L5? Oh, it's 8. What's the minimum number in L5? Ah, that's 1. Notice, just like with sorted, these functions don't change L5. They just go and find the smallest or the largest in it. And finally, a nice one to do is sum. What is the sum of all the items in L5? And we see that it is 30. So this gives us a little bit of an introduction to lists. Remember, a list is a collection of items. It can be a collection of anything, even lists of lists. We saw that. But it's also a sequence, so it's an ordered collection. And we will find ourselves using lists frequently in this course. It's enough for now.